we're going to pick up back on our build series here and go through the cylinder heads. Go ahead and get the cylinder heads bolted on the block, get the valve train set, get the lash adjusted, and I think we might actually end up getting to adjusting the timing set and getting all that timed up. Here we go. This one's probably going to be a little bit of a long one. Hang in there with us, and we'll go through getting this engine back together and get it ready for SCT this weekend. Alright, we're going to clean these heads up a little bit. We got this nice little carbide scraper here that we use to get all the crud off of the deck surface without gouging. A little bit of a daunting task here, especially where it's got O-rings in it, but it gets all the grime scraped off there. Then we can wipe it down with a nice little towel with brake clean and get it nice and spiffed up. And normally you would probably take these and have them decked, you know, cleaned up a little bit. Usually they can take, you know, 1 or 2 thou off of it and basically scrapes the head for you. That way you don't have to do this. But where this has O-rings in it that protrude up, you'd have to take those O-rings out, and that's a MF'er to do that. We have big copper gaskets. I think they're about 70 thou thick or 60 thou thick. I can't remember. That's going to take up any little slight variation anyway. Plus the O-ring is what takes all the load from cylinder pressure anyway. So to give you an idea of how good this O-ring setup is, when I pulled this motor apart, you know, it had about 70 passes on it. In the past, I had never really gone back and retorqued the heads. I've never really had any trouble with that because these things torque so high with the big 1/2-inch head studs that, you know, I've never had any trouble with head gaskets leaking or anything like that anyway. So I was taking this motor apart last fall, and I thought somebody was playing a joke on me because whenever I took the big 1/2-inch ratchet to break the head studs loose, well, I about yanked myself into the floor. Come to find out, I guess the gaskets had compressed over that many passes and that much cylinder pressure, and they really needed to be retorqued again. I used a torque wrench to break a couple of the other studs loose, and these center 6 holes here only had 38 pounds of pressure to break loose. Now the crazy thing about that is the very last pass that I made with this motor was on 62 pounds of boost, and it didn't blow a head gasket. So the 1/2-inch studs only had 38 pounds of torque on them with this O-ring and copper gasket setup, and it still didn't blow a head gasket. Not even carbon traces. So it's crazy. That's why I preach on anything methanol that's trying to make big power. You're crazy not to just go ahead and O-ring stuff. It's literally the only way to really make these things really survive. Now I will say it seals the system up so well that your head gasket isn't the weak link. It's not the fuse anymore. So whenever you remove that fuse, well, the next fuse is going to be the next weakest link naturally. So if your tune-up is off and you're blowing head gaskets left and right, and you theoretically shouldn't be blowing head gaskets left and right, well, you do this system, it's not going to blow head gaskets no more, but it's going to start bending rods, it's going to start breaking pistons, it's going to start bending or breaking cranks, or, you know, tuliping valves, or, you know, any of the multitude of other things that could relieve cylinder pressure at the wrong time. So note to self, if you're blowing head gaskets now at 1,000 horsepower, don't O-ring your sit-up. It's the tune-up more than likely. So, or you need a better casting head that is capable of holding a gasket too. You know, these guys that's trying to run stock casting gaskets, the casting itself fatigues over time and loses its rigidity, won't hold a gasket anymore. I know all you guys know Pt2. He's commented on this quite a bit in the past. where he could run his little 5.3 really hard on stock 243 heads up for so many passes, and then, you know, after a certain amount of passes, even with his same tune-up that has gone down the track multiple times, the head lost its rigidity and it wouldn't hold a gasket anymore. So there is such a real thing as fatiguing the cylinder head in the casting. The O-ring process definitely takes some of that out of the equation. You know, that's why it's really nice to run a quality casting. You know, we run CID castings on this motor. We'll continue to run CID castings until somebody proves to me otherwise that it's not the best head on the market, at least an inline head. I say inline head, they've got their SC2 heads out now for the LS stuff. That's probably what I'd be going with next if I was staying a solid roller. But to be quite honest, the maintenance and upkeep on a solid roller hasn't really been my favorite thing. Obviously it does make power, it's very stable valve train, and you know, all my old hydraulic roller combos, I never had valve train problems. You know, my old trick flow headed combo that made just shy of 2,300 horsepower on pump E85, that was a complete legit street car that I could drive anywhere. You know, it still had a 15-gallon tank in it. You know, I could literally drive that car to Florida and not even be uncomfortable, really. But anyway, the only time I took valve covers off was to change rocker arms. We swapped to some of the BTR V2 trunnion rockers on it at one point, and that was about the only time I ever pulled the valve cover off of that motor. I can't say that about this. I've had to replace lash adjusters, I lost count of how many times, probably 5 or 6 times in the last 3 years, I guess, maybe more. To help try to remedy that, we actually recently got up with Manton, because Manton makes all the really nice high-end solid roller lash adjusters and push rods and all that good stuff. They actually do a lot of the valve train components and top field dragsters even. I called them, let them know what I had going on. They were like, yeah, we get you fixed up. So they got me some tool steel or some kind of billet material. I don't even know the specifics, so don't hold me to the material here, but anyway, it's a superior material lash adjuster. I had trouble with push rod clearance on these heads here, so I went on and actually went with a little bit smaller diameter. I had a double taper, 3/8 tapered to 7/16, and then tapered back down to 3/8. Well, that fat middle really screwed me on the intake port here, because you know, they would rub or whatever. So anyway, while I was ordering the lash adjusters, not to get off 5 tangents here, I went on and ordered a new set of push rods, and I had them put oil restricting push rod tips on the top side because I was having oil control issues. They also made it out of that better material as well, because whenever those lash adjusters break, it usually takes a push rod tip with it. So I've had to replace push rod tips and lash adjusters prior to updating to this new adjuster push rod combo. So we've only got about 15 or 20 passes on this new push rod tool steel adjuster combo, but so far so good. We haven't broken anything and the lash stays dead on. We're thinking we might have that part licked now. Plan on getting these heads all cleaned up here, and we will get them reassembled, check all the valve seals, go through the assembly process. So I'm gonna quit talking here and try to get to work and focus here so I don't miss something, and I'll speed y'all up so you can see this work a lot faster, so you're not sitting here for 3 hours watching me scrape a cylinder head. go ahead and clean this other head too. Do a little different here. I got some mineral spirits and a brush. Okay, got the heads cleaned up and reassembled with the new springs. So now we're going to go over here and get back on the short block. I've got to put the cam in it. We've got to put the timing chain. We've got to put the batwing little chain dampener. Then we've got to, I'm not going to bore you with cleaning the oil pan and all that stuff, windage tray. We've got to put the windage tray and oil pan and all that stuff on the bottom end as well. But we can show you cam timing and degreeing the cam and stuff in. We'll get you set up over here and we'll get to putting the camshaft and all the valve train stuff in the motor. So, okay, got all our cam stuff here. I've wiped the cam down, get all the greasy, grimy, oily stuff off of it. Got a new little batwing from GM here we're gonna put on. I generally try to replace these about any time I'm in the motor. Because on a solid roller combo like this, the chain slap is pretty violent and then it kind of wallers out these little things here. So yeah, we just go ahead and try to put new ones on each time. So plus I didn't know where the old one was either, so I had this sitting here. I have a couple of these on the shelf that I keep, and like, well, I'll just put a new one in there so I don't have to worry about it. So get this put on and get her torqued down. Old trusty snap on. All right, set that aside, we'll probably need it again. So, like I said in the earlier video, this block has been line bored to put new main caps in. So every time you line bore or line hone the block, the saddle that the crank rod's in the block theoretically gets material taken off of it to clean it back up. So this block has been line bored probably 4 times. You know, I've had some thrust issues in the past with this motor, flexing cranks, taking out mains again. So this poor block has been through it. So the crank center line has definitely moved up some. So the standard chain that I've got here with the hex adjust timing set is probably not going to work. We'll probably go ahead and put it on there just to see if it does hold up, if it doesn't have too much slop in it, but I'm gonna guess that it probably has too much slop. So I've actually got this double roller timing set from JP Performance. It uses a IWIS Performance chain, and it's a double roller, but it's actually designed to, the gears are machined to be a little bit bigger in diameter, I guess, or the chain links are just slightly shrunk. I'm not exactly sure exactly how they do it, but needless to say, this timing chain is set up for an engine that has a closer cam and crank correlation. So this one, being the crank's moved up, it's closer to the camshaft now, so a brand new timing chain is probably going to be sloppy. So this timing set here is going to take up that extra slop and be a lot tighter. So worst case, if the hex adjust single chain that I normally run is too floppy, we'll probably go with this timing set here. So yeah, I brought both of them over here just to get all that taken care of. I'm gonna lube up the old camshaft here and get her ready to stick in there. Everybody knows she likes her lubed up. Look up that torque spec real quick. I think it's like 12 or 15 foot-pounds, but cannot confirm or deny that. Fun fact, LS engines came with two different style bolts. The OG LS1s, some of the LS2s. Early LS engines had like a regular 10mm bolt that's like the same 10mm that they use for the front cover, the rear cover, the oil pan, the camshaft, the oil pump. Those torque to 18 foot-pounds. Do not torque the Torx ones to 18 foot-pounds because you'll probably never get them back out. The Torx ones torque to 11 foot-pounds. And this is going off of GM torque spec. I actually pulled up the GM document. Pace Performance is the first one that pops up on Google whenever you type in LS3 cam specs. You can't go by that one though because it's referencing the older style bolt style. So I looked up LT1 torque specs, which is the newer Gen 5 engine, but it still uses the same cam retainer plate with these same exact bolts. All of the LT1s had the Torx bit bolts in them. So, and that torque spec is 11 foot-pounds. So we're gonna turn this little puppy down to 11 and sand her. Got a bit onto it. I haven't got to bite. I think I already got that one. I did. All right. Our cam retainer plate is torqued. So number one thing is we need to get our cylinder on top dead center. So the pin to the right is going to be TDC for the cam itself. You can also tell it's TDC by looking at your cam sprocket, and there should be like a TDC point. Now this is actually using a sprocket for the hex adjust, which I'll actually have to remove if we end up having to swap to the other timing set. Hopefully we don't, because that thing's pressed on there and it's pressed on there good. I really don't want to change it. But irregardless, worst case, you literally look at the piston and you'll see that there's a dwell spot where it's just going up and kind of stopping for a split second. But that right there is basically TDC. As Those big old stiff rings in there are, yeah, they're stiff, so it's hard to turn the motor over. I do have ARP cam bolts because I have had those things back out in the past, so I always use ARP bolts on them now, and I over torque the crap out of them. That way they'll never come loose on me. Never broken one. I usually torque them about 30 foot-pounds or so. So I'm gonna wipe this cam gear off a little bit. We'll see how loosey-goosey this timing chain and cam sprocket is on this motor. So this hex adjust setup does have a Torrington bearing on it. That way you don't actually have metal to metal contact on the plate. There's enough oil in the engine that it doesn't really ride metal to metal, but the cam is still going to be rubbing on the back side of this retainer plate. There's not a Torrington bearing on it, but on the cam gear side there's a Torrington bearing that spins, so there won't be any wear on the front. So what I'm doing here is took the chain off. I want to slide the sprocket onto the cam here, get it positioned in a way that all my bolt holes and pin line up with the crank here. Now I always do an end play test. It's going to be a little bit harder to do on this one because that cam bearing a little bit tight on that one. Oh yeah, we got play. I like to have, you know, a pretty good little amount. Now as you can see, let me load this one way. So this side's tight. And this is how sloppy our chain is. So that's bad news for us because I can get my full finger in between that chain and that bat wing there. So that tells me that we are definitely going to have to pull this sprocket off and put the double roller on it. Start zipping this all back apart. So our 0 degree slot is right there. Wouldn't you know it, it presses on. So I'm going to leave that somewhat loose a little bit, and we're going to take this keyway back out, so if I need to change this I can pull it off and spin it without having to take this bolt back out. So we'll line our TDC spot up with our 0 degree mark. So now what we're going to do is use a dial indicator here to get our true top dead center point. Now I've got to zip my bolt back off again and put the degree wheel on. The fun part's always getting the thing to spring where you want it to. Alright, so that's on TDC right now. So what we're going to do is roll the motor over one way and see what our indicator does. So we're going down, which means we're past TDC there, so we're going to go back up the other way. It looks like we're already pretty close. So now what we're going to do is use the indicator to go, oh, I don't know, let's just go 15 thousandths on either side. So what we want to do is get it right on that 35. So a lot of times what you can do is use your leg strength, rest this up against your knee. Okay, so right there we're 5.5 degrees on the right side of TDC with it at 35. So remember that, 5.5 degrees to the right of TDC. So now we're gonna go the opposite way on the other side of TDC. So I'm gonna go a little bit past it and then come back. We'll almost hit it right there. Within probably 1/10 or so. Nope. This is something you've just gotta kind of play with and just bump. Okay, right there, we're at 35. So here we are at 8 degrees. Maybe call it 7.5. So that tells me that even though our gauge peaked right here at TDC, there's piston dwell. So there's about 2 or 3 degrees in that range where the piston doesn't really move. So that's why I always measure the piston on both sides with the piston going down and mark the degree wheel. That way I know where true TDC is. So what's happening here, we're 5.5 to the right and we're 8 to the left. Well, you add those two together and split the difference, and that many degrees to the right is where TDC is. So what I need to do here, you're my calculator, so let me go in here and grab my other spare telephone and get my calculator going. I would do mental math, but my mind is baked right now. So theoretically, 8 plus 5.5 is going to be 13.5, right? 13.5 divided by 2 is 6.5. So 6.5 degrees back from 8 is going to be 1.5. So basically, let's go back to 1.5 degrees to the left of TDC. And that is gonna, it should be TDC. Now you can watch the dial indicator and see if it ends up close to 0 or not. And according to the dial indicator, is dead on it right there. Now we have our true TDC spot. What I'm gonna do is move our pointer, try to bend it into the correct position. Hey, we're dead on it right there. Now the fun part. Now we get to move this hunk of junk again and measure our lifter. Coming around to our intake open point. We'll go around all the way to the 50 lift, which is 1 revolution on this indicator. Dead on it right there. So our intake open degrees. Now let's go see what our intake close is. Now just to be sure my indicator's right, I'm gonna go past it back to the base circle. Yeah, I can see it's actually lost a little bit here. So what I'm gonna do is re-zero it out and go back to it. Yeah, see, that's more like it. It's 63.5 actual. So we're really, really close on our numbers now. I think the actual specs had a 64, it's either 62 or 64 close. So we're definitely in the ballpark now on our intake. Turn that rotation crap off. All right, now always like to just triple check our exhaust. So we're gonna swap it and put it over there. So our intake is just closed, or it's closing right now. So theoretically we should be on the base circle on our exhaust. So I should be able to zero that out and check our exhaust open point. Pushing the piston down, it's only moved 52 degrees before that lifter starts moving. Now, I will say this thing has lash. It's supposed to have like 14 or 16 thousandths of valve lash. Theoretically, the valve isn't going to start moving until we get about right there, which is already down past 80 degrees. That is with the solid roller, you're going to have a lash ramp on it that is a good solid 15 to 20 degrees, depending on how the lash is set up on the cam grind. So most of your solid roller cam cards will have a lash indicated on there. And that's where you need to set the lash, because that's where the lobe has been ground for the actual valve lift to take place. So, went just past it, but it looks like it's going to be pretty close. It's like about exhaust open. And let's go on around to our close point. It's going to be just after top dead center. So this coming up on 0 here should be our exhaust close point. This is the one I'm actually really curious at, because I don't want it to be any past 20 degrees because of piston to valve. Right there is dead on the, it looks like we're about 21, unfortunately. So same deal, we're gonna go on past it to our base circle, make sure it went to 0, and it did. So we're probably actually gonna be close to 21 degrees, even though I didn't want it past 20. Hopefully that 1 degree and our new springs hold us over. And that's about 20 on the dot. So that's what we're going with. It's actually what it's supposed to be, is 20. So that's a win right there. The cam is right where we want it to be. That's the daunting task of degreeing in your camshaft. So now we can zip all this apart, and I'm going to put Loctite on these cam bolts here and get those torqued down, and then we will be ready to check clearance on our front timing cover, because I'll probably have to notch some of the stuff on the front timing cover to clear this double roller timing chain. And I'll have to also check the clearance on the cam pickup. Now this is recessed, you know, the chain sticks out, so as long as the cutaway here is good to clear the sensor, we should be good. But it's still a good idea, once you get the front cover put on, that you check with a depth mic how far the little reluctor ring is from the actual sensor. I don't really have a spec of what you want, but I know the crank sensors are from the factory, they're like 17 thousandths away from the crank reluctor. Now the cam sensor might have a little bit more tolerance than that, but I would still want it to be within at least 50, I think. Most Hall effect sensors need to be at least 50 thousandths air gap. Any further away from that, and it starts seeing trigger issues. I'm gonna speed this up for you guys and get this thing tore apart and torqued down. Like that boss right there. All right, so what I ended up having to do was cut this little spot right here, which is the boss for the bolt for the cam sensor. I just took a little whiz wheel and just notched it, and she clears perfectly good now. Little brake clean to clean all the aluminum powder out of there, and this thing is good as new. It'll go right on there now and sit all the way flat. Now, naturally, the gasket's gonna hold it up off of that a little bit, but the fact that it goes all the way against the block without any effort is a plus sign. We'll probably go ahead and put this thing on there, but I'm not gonna tighten it up yet because we have to get the oil pan and all that stuff put on. Pretty good habit of putting new gaskets on about every time I take this thing apart, and this thing got taken apart very recently, and I put a new front cover gasket on then. So it's got a little bit of RTV caked up on the bottoms here, but that's okay because I'll likely wipe that down real good, and we'll probably end up with more RTV down there because they always leak in these corners if you don't put it. So the new GM silicone little white, looks like Honda Bond, that stuff is awesome. Use that in the corners instead of Permatex, and it'll seal up even better. So, but for now, I'm gonna come kind of eyeball this centered, and we're gonna zip her down here. We really just need the top few bolts to check. It looks like our ridge is up, so I'm gonna get my calipers, which have a depth measuring portion. Anyway, what I'm gonna do is zero that out at 0.003. So now we're zeroed out, so any depth that we get from here on out is gonna be true to this base. So what I'm gonna do is hold this as square as I can and run that end in and touch off of that you can tell because the base is pretty square on this thing. So once you get it perfectly flat, you can kind of run that in. So it looks like we're 1050 on the dot. So now what I'm gonna do is literally measure here. So I'll have to zero my thing out again. So remember, 1.050 is our depth. So let me zero our thing back out, and let's measure from the little post here to the end of our sensor. Looks like about 990. So 1050 minus 990 is going to be about 60 thou. That's probably a little bit far, but it's clear. What are you doing?
Dinner's ready.
Dinner's ready. You want to tell YouTube hi?
Hi.
We're going racing next weekend, ain't we?
Mm-hmm.
Yep. We're going to win? Yeah. I like that confidence. You can be a drag racer whenever you get a little bit older?
Yeah.
Yep. What kind of car you want?
Corvette.
That's right. I like Corvettes too.
I call them Corvettis.
Corvettis?
Yeah. It has an E at the end, and I don't notice it, so.
Yeah? So, what kind of Corvette do you want? You want one like Papa's? Or you want one a little bit newer?
Probably a newer one.
Like how new?
Probably like from 1 year ago.
You want a C8?
Yeah.
Yeah, I can't afford that. You better get a job.
Yeah, totally gonna get a job, totally.
I think we need to get you like a C6
Probably.
because a C6 is still an LS and they're cheap to mod.
Don't ask me why I'm wearing mom's shoes right now.
You are, ain't you?
Yeah, I didn't bring my shoes out, so I had to wear my mom's.
Oh, yeah.
Oopsie.
Well, let's go eat dinner. I'll get back to y'all in a little bit. Balancer put on. I think we're bottomed out right there. And as I put these in, I'm gonna oil these up down in here. That way we don't lose any oil on the ground here. And what that's gonna do is bleed all the way around the bore and really get down where it's supposed to be. You want that to be well lubricated whenever you put that in there. Looks like our other ones are still lubed up real good. I'll give them a little extra squirt there. That way there's a little extra lube. Set and ready to get our head gaskets and head studs in order, and probably start on the driver's side first. The cylinder deck has been surfaced and cleaned already, so we're literally ready to wipe it down and put the head gaskets on. We want to do one last double check on our cylinders here. So I kept this clean cloth here on purpose because I wanted to wipe the cylinders before putting the cylinder head on and sealing the motor up. This is one of my previously used copper gaskets, and normally I don't do this, but I've reused these in the past, especially if they come off of the same block and using the same cylinder head back, because what's really holding the compression is this groove here that is going to be located by the block and the cylinder head. So all this will mesh right back together just like it was whenever it first compressed it. Now the other thing, this block has now been decked a little bit. So it's just been surfaced to clean it up. I don't really know how much it took off, probably just enough to clean it up. But what that's gonna do is gonna shallow this groove a little bit, which is gonna make this protrude a little bit. So whenever I clamp this gasket back on with the cylinder head, that ring is gonna compress this again. So I've wiped it down real good. And cleaned it up, but yeah, so basically that just sits on there and you can actually press it down and it's actually locating right back into the cylinders there, which is exactly what we want. So make sure we didn't have anything residual sitting on the deck surface. And we are down and located.
So you can see that that head fell right back down in its original spot. So the one thing that we won't have trouble with this time, where this gasket is already compressed once, whenever I tighten these studs up this time, it's not going to be compressing as much copper this time, so the requirement for a retorque will be a lot less likely. See, whenever we pulled the heads off of that other block, I just put brand new head gaskets on that motor, and where you torque it for that first time, you're compressing the copper down into that O-ring for the first time, and a lot of times that copper relaxes over time when it's under constant pressure. It's a malleable metal, so and then naturally us racing it, you know, cylinder pressure, you know, vibration and everything else kind of moves everything into its position. It's probably why it lost some torque. So we shouldn't have that problem with these used gaskets, and I may regret this, but we'll see. We don't run water in this engine anyway. It's all concreted, so even if it does seep a little bit of compression out here and there, it's not the end of the world. So I know we're talking about we want to keep all the compression in the cylinder to use pushing the cylinder down, piston down, but we shouldn't have any pressure issues with the O-ring setup. Seeing that that one was holding just fine with 60 pounds of boost with 38 pounds of torque on the head stud. All right, missing a little bit of hardware, but some of it got mixed and matched up with the dart block stuff, and luckily the LSX nuts and washers were in with the dart block stuff. Either way, at least we got nuts and washers to put this engine together, and we'll have to worry about that one later. So what I'm going to do here is go ahead and start putting this together. Basically what I'm going to do is just thread the nuts down on here a little bit, and I've got this little brush here that has the fastener lube, torque lube, whatever you want to call it. We will literally just brush that on the threads, and I like to brush it onto top of the washer as well, this way that the nut on the threads is lubricated and the washer itself is also lubricated. Now you have that assembly ready to drop in to the engine. These things torqued 110 foot-pounds, so we're gonna do 3 steps. So another thing that I wanted to tell y'all about, it's a 6-bolt block, and you notice whenever I put the heads on, I didn't put the inner stud in. I don't do that anymore because if I need to pull this head off at the track, that would require a lot more work. Plus with these link bars, you have to roll the motor over to get clearance for the wrench to get in there to get the nuts off.
And even once you get those off, the link bars are all in the way to, get the nuts off of there and out of there. And doing it inside of a car is even worse. Doing it here on the stand may not be that bad, but yeah, in a car, no. So the other thing that I've noticed is, have you ever seen a head gasket blow up? Me personally, I haven't. So that's why I don't put the inner studs in anymore. Now, this is where the dart block is superior, in my opinion. It just uses these tiny little studs here for the 5th and 6th head stud or bolt on an LSX block. What they were thinking, it's an aftermarket block. It should have come standard with 1/2 inch head studs. Should have come standard with 3/8 or even 7/16 at minimum on this bolt hole, because every time I've ever blown a head gasket, it's always been down this way, right where these bosses are. So having a stud that's equally as strong right there where they always blow goes a long way. Now 3/8 studs leaps and bounds better than these little 8mm studs, but I guess something's better than nothing, but I really don't think these little studs do anything. So anyway, figured I would put in that little bit of tidbit info. Last night I went on and put all the rockers and stuff on this side and got this side complete. It's torqued down. I've just got to finish torquing these little studs and run those in, and then we'll go to putting the other cylinder head on. So what we got here, we have a set of Crower rockers, specifically for these solid roller CID heads. And you'll notice these adjusters here, get it to focus. These are the Manton push rods with the tool steel tips and the lash adjusters. These are the ones that are supposed to not break. That's the ones on the Crower combination that I've had really a lot of trouble with. Now you'll notice, looking at it from this angle, that I don't know if you can really see or not, but look at the angle of this push rod. See, back up here, this push rod goes up to here. So see that angle? And see how the rocker is kicked and offset, to this side? Well, that's to really gain clearance for this port right here. So the only way to really get, I guess, that big of a port and that straight of a wall and all that fun stuff is to offset the rocker. And it does inevitably put a pretty steep angle onto the lifter itself. Now the exhaust side looks like it's pretty well straight up and down, which is actually a good thing, because the exhaust side is more prone to valve train failure.
valve train on. This is a Crowder shaft rocker, just like the other side. So now we got to torque the base down. This base torques down from 40 to 45 foot-pounds. Now we have to set the push rods in. Also, this is where you never want to forget your lash caps. Lash cap, lash cap, lash cap, lash cap. Intake port, titanium intake valve, intake port. You can even see the way the port runs down in the cylinder head. No, this is the intake. Also, you can also tell because with the lash cap off, it's a shorter stem than the exhaust. The exhaust is an in and out, doesn't require a lash cap. Even though you could run one, you don't need to. I did this last night off camera and just to triple check myself, lash cap, lash cap, lash cap, lash cap. I always keep these rockers in order so they literally go back on just how they come off. I'm getting ahead of myself because I got to put the push rods in first. Being on camera, you kind of lose your train of thought here on the process, but irregardless. So this is our Manton push rods. This is the tool steel tip with the restricting hole. This is the standard tip. So the standard tip's gonna go down. What I'm gonna do is, since I have this valley open, right now is the easiest time to check the push rods because you can physically see that all of them are going in to the lifter. It's so easy to miss the lifter cup, especially in a cylinder head like this where it doesn't really have a lot of line of sight to the lifter. This is always a good way to do this. And we are in the lifter cup. So another thing that you'll want to do before you get to putting the rockers on is, especially on a solid roller combo that has a lot of seat pressure and a lot of open pressure, you know, naturally this doesn't have any oil in it yet. So you'll want to use your assembly lube to lubricate all the valve tips and lash caps and lubricate all your push rod tips. And what that's going to do, it's going to give a little bit of lubrication on that until it starts seeing oil from the oil pump. Now I'll go ahead and do all the push rod tips. This is also a good time for you to physically put your eyes on every push rod tip to make sure there's not any premature wear or anything of that matter. Okay. Now we can go ahead and start putting our rockers on. I'm gonna get my trusty little torque socket here so we can start getting those things run down. Now this is also, whenever you put the rockers on, you want to make sure that you get that lifter or the push rod tip into the rocker cup, because there's a lot of pressure on these springs and you really don't want that push rod to be, you know, hitting on the side of the rocker or something else. You can really damage these rockers and or push rods or whatever pretty quickly if you don't have that set up right. Now this is a very messy job, so you're going to get grease and grime all over you, just part of it. Okay, now's the time to make sure all our push rods are in our rocker cups, and it looks like everything is good there. We can start running these rockers down. Now you don't want to tighten the rockers up if the push rod is up. So you can easily tell, see this one has lash, see how it's rocking, and it's pushed all the way down. That means we can go ahead and tighten this one down. These right here I've already done. See, this one's up a little bit, but what I can do is run that up and we'll roll the motor over. This one has lash, we can run it all the way down. This one right here has lash as well, so we can run it all the way down. See how that moves? This one right here looks like it's got a little bit of lash, so we're gonna run it down a little bit. Feels like it's got just a smidge bit of lash, you can still move it. This one right here is up, so we're not gonna mess with it yet. So this is where we put a bolt in our balancer and roll the motor over and watch for the ones that we still have to put down. This one gets harder to turn because I've got spark plugs in this. So this one right here is going down. Okay, this one's all the way down now. So we can go ahead and zip that one down. So all these are tight. The only one we're looking at is this one, and it's almost down, it looks like. Let's go ahead and run that down some. We'll roll it on around a little bit and get that down on the base circle, and then we'll tighten that one up. Okay, that one is fully down now. So let's zip that one in. Now we have all our rockers tied down. So we need to torque those now. Now those bolts get torqued to 27 foot-pounds. It's also never touch the head of the thing whenever it's torquing zero, because if you're sitting there messing with it and it's trying to zero out, it might throw the torque off. So you can always hit the power button and it'll re-zero again. And that way you can know for sure that you're torquing your fasteners to the correct torque spec. Now obviously if you, yeah, I went too high on that. I noticed it wasn't set for 27. Click type. You don't have to worry about batteries and all that other hoopla. It will just click whenever it hits the right torque. So let's retorque that one. I've got it set to 27 now. Good. Generally it's not good to torque them while they're down like that, but it's okay. It'll still torque. We can come back to it and recheck it again to make sure it didn't prematurely torque. I'm just going to go down and tighten all of them up. That way we're at least tight. Okay, now let's roll the motor over. Let's see, this motor's never run since this freshen, and that thing still got compression. So I'm just making sure all the valves are making contact and the rollers look like they're in a good position. Flash caps are in a good position. Now let's retry these torques here. Yep, see it? Even though it was down, it's still torqued. All right, got everything cleaned up. Got the windage tray put on. Still have to tighten the front cover up, put the rear cover and the oil pan on. I've been basically cleaning the oil system up for the last few hours. Obviously the last time this thing was running, we had a thrust bearing issue, so wiped out a bearing. So there's bearing material throughout the whole oil system and oil pan and oil filter. I've got to take the oil pump apart still and clean it out real good, make sure it's not damaged, which it shouldn't be because it was literally holding 100 psi of oil pressure even with the spun main. So now we've got to put our gasket on, put some RTV or the GM assembly stuff on the front cover. I'm not going to do the rear cover until I'm ready to set the motor in the car, because really to get access to this back cover, you really need it off the stand. The bulkhead here is in the way of it. I'll wait and put the rear cover on then. For now, we're just gonna go ahead and get our silicone for the front cover. And what I'm gonna do is pull this front cover off a little bit, back all the screws out, because really all we need to do is squeeze just a little dab of RTV right in this corner where the front cover, the block, and the oil pan all meet together. You know, that's always a leaky spot in those corners where 3 covers meet up. Now, this cover won't come out very far because obviously the balancer on there, and this particular balancer has a cog drive on the back side of it. There's just enough gap there to where we can squeeze a little bit of RTV down in beside that front gasket. So generally I'll put it on the behind the gasket and in front of the gasket. That way it's got plenty of sealing surface there so it doesn't leak. Back to using this carbide scraper, that's another thing that's really good at it. One swipe and it pushed that RTV right off of that bottom of that cover. You have to be careful not to gouge it. You can, you know, help roll it up and deliver stuff. Whatever your method is, doesn't really matter. You're just trying to make it seal up. I know these aluminum rods and stroker motors are sometimes a pain in the butt to get rods to clear. All right, fellers, got all the cars moved around and got this thing lowered down and prepped. Not really much to prep here, but anyway, got the motor hanging. I've got to torque the harmonic balancer on, but I'll do that once I get it in the car, get the flex plate put on. Right now, we're working on the rear cover. So any of you that have worked on an LSX block know that this is the biggest BS thing that they ever did on this stupid block. So what we've got here is this BS. So as you can see, get real close here, that's a square cut groove with a round gasket to go in it. It won't capture it. So what do? How do you keep that little rope in there? You got to cake it on with this. It's the only way. So after I got everything cleaned up, got all the old RTV wire wheeled off of it and everything else, you got to turn around and put RTV right back all over it. So that's what we're going to do now. I'm going to show you basically the key points to dab it. Basically, I put dots on all these little corners where it's prone to actually falling out or coming out whenever you flip it up to slide it onto the engine. And what I'm probably actually going to have to do too, I'm probably going to have to take that oil pan back off, or at least loosen it up, because what's going to happen whenever you go to slide this cover on, you know, naturally the seal is going to, you know, conform to this crank. Well, this oil pan is tight, and this gasket being new, somewhat new, this, you know, rubber seal here is poofy. Well, the oil pan's pushing it up. It's actually bowed up a little bit right now because it didn't have the cover on it. So we're probably going to have to drop this pan back down, which will drop this gasket back down so that this gasket doesn't interfere with the rope gasket that's on the rear cover and cause it to pull that rope gasket down and off. Because there's nothing worse than putting fresh RTV on and the rope falling off and having to take it all back apart and have to clean up all the RTV that you just put on there and make sure it didn't get into an oil galley or something else. I've got the oil pan dropped down so it doesn't interfere with the bottom here. Let's set our rope back in there. Now what I'm going to do is leave that just a smidge long, because once we get this glued into place, I'm going to take these dikes right here and snip the end flush. And then we're going to put a dab of silicone RTV on the bottom there. So now what I try to do is take this RTV here and literally what I'm going to do is dab it, just put a dot like that, and that somewhat holds it into place. Be firing this thing up anytime soon, so what I'm gonna do is obviously let this crap cure for a day or two before we fire this car up. And if there is any RTV in the oil galleys, it's not gonna hurt anything. So this is the bullshit that you gotta do when you got a freaking junk ass LSX block. This is why you should just put a dart block on everything, because holy shit, this is dog shit. Pardon my French, I'm sorry, but this is retarded. Pray for me. All right, that motor is sealed up. Go find my other 2 bolts, put the flex plate on, and we're gonna set that puppy in tonight. I got a little bit more to do, but it's all smooth sailing from here. Just basically got to get all the hot pipes, the charge pipe, fuel system, headers, starter, pulleys, and tighten the rest of the bell housing bolts up, get the torque converter bolts put in. But we are on the main finish line here. Won't be long, we'll hear some percussive music.
Yep.
Hey guys, we are finally finished with this thing, at least motor wise. Later this evening and tonight I've got to change the rear end stump. We're going to change the gear ratio, try to make it a little easier on this old wore out LSX cast motor. Had good oil pressure, holds 100 pounds at idle. I did spend a lot of time the other night. We went through about 6 or 7 hours worth of testing on both the primary and secondary injectors because they're two different sizes, and characterized everything really well, especially at the low pulse width. And we got a new injector bench that I've outfitted with a Haltech ECU. My VE table was suffering quite a bit at idle and part throttle. It would go really rich and really lean in spots, so a lot of that's because the injectors weren't characterized properly. These are FID 2750. They're modified Siemens Deca 220s. Those are what I have in the primary, and I have just a regular set of box stock Siemens Deca 220s as secondaries. I really need to get those sent back up to Tom at Fuel Injector Development to get those modified as well. On a lot of boost, we are actually stretching these injectors really tight. I also have Bosch like 1500cc. Some people call them the 1650s. All stainless or whatever. I did have some Bosch 220s in there, but whenever I checked them, one of them was actually stuck. So those injectors are really bad and known to kind of stick a little bit. We didn't really maintenance this thing like we should have. In a perfect world, I did exactly what I tell customers not to do, and we left the injectors and everything sitting in the intake manifold and the charge pipe over here for 6 or 8 months with methanol sitting in it. But luckily, the shop is mostly climate controlled all winter. You know, we have natural gas heat out here, so there's not a lot of moisture in the air, thank goodness. So the injectors didn't end up having any rust or residue. They were just simply stuck. So we put them on the bench and pecked it with a screwdriver a couple times, and it popped right off. And believe it or not, the flow rate and everything was exactly what they were whenever we tested them a year ago. So the Bosch 210s were still in good shape, but I didn't really want to chance them sticking again, and I had these 1650s here that are a little bit more reliable in the pintle sticking aspect of it. We weren't using the full quantity of the Bosch 210s anyway. We stuck these in there, and we're going to run them a little bit higher duty cycle to compensate for, you know, the smaller size, but they still flow plenty enough for what we inject through the charge pipe. We generally try to inject around 10% total fuel flow through the charge pipe. So this engine has consumed roughly 5,200 pound per hour of methanol total. So we want to inject around 500 or so pound per hour when we're flowing that 5,000. And at the base pressure that we run, these injectors are a little bit shy of that at 5,000, but it's very seldom that we run 5,000 pound per hour. You know, that's like 60 pounds of boost, you know, full boogie. That's whenever you get lined up against one of those Proline Hemis with twin 98s on it that's 400 or 500 pounds lighter. You got to throw the kitchen sink at this poor little LS motor 3,000 pound car. So that's whenever we use the full capacity of everything in the fuel system. So yeah, we're going to get everything tidied up, change the rear end tonight, and check for leaks and check fuel levels and oil levels and all that fun stuff. Wipe everything down. I've already done some nut bolt check. You know, the car's been sitting for 8 months, so I went over all the 4-link, all the lower control arms on the front, you know, just everything that's accessible and could vibrate loose. Transmission bolts, bell housing bolts, of course those just got put in. Yeah, I think we're ready for SET Indy. We're gonna get this thing cleaned up and loaded up tonight and head out first thing in the morning. So hope to see you guys there. And if not, cheer us on from the internet, and hopefully we can bring home the big W.